Hello everyone, hope you all are doing well. So today we will start our new topic, that is law of conservation of momentum. So first of all, we talk about the definition of law of conservation of momentum. Law of conservation of momentum said that when two bodies are collided in isolated system isolated system, the total momentum before collision and after collision will remain same, or you can say conserved. Okay, so this is the basic definition of law of conservation of momentum, that when two bodies are collided in isolated system, the total momentum before collision and after collision will remain same or conserved. How? So let me show you. We should make first one diagram for explanation. Let's suppose this is first mass m1, first body, this second body. Okay, this body known as m1, mass 1, and it's called mass 2, m2, with the initial velocity u1 and u2. Okay, this happens before collision. Okay, but after collision, what happens? These both m1 m2 collide together, and after collision, when it's separate again, so we receive m2, again we receive m1 m2, they are the two masses, and we receive that the velocity v1 and v2 of them. Now here we have considered two bodies with unequal masses m1 and m2. Let me write an explanation of that. Okay, explanation said that consider two bodies A and B with unequal masses m1 and m2. Okay, we have to consider two bodies A and B with unequal masses m1 and m2. After that, moving with the velocity of, I will write here, moving with the velocity of u1 and u2. This is the initial velocity of that u1 and u2 before collision. It happens before collision. After collision, what happens over here? That their velocities become v1 and v2, means their velocities become final. After collision, their velocities become v1 and v2. Okay, so let's suppose, according to explanation, we will make a diagram of it. This explanation say that consider bodies A and B. So we have considered two bodies A and second body B. Okay, with unequal masses m1 and m2, with moving velocity of initial u1 and u2, but it's collide over here, okay, to each other. After collision, we receive the two more velocities that become v1 and v2, means final velocity. So this is the explanation of law of conservation of momentum, that as you can see, in starting we are having same u1 u2, in ending after collision we are having remain same. So this was a diagrammatically explanation of the law of conservation of momentum according to their definition that two bodies collided in isolated system, total momentum before collision and after collision will remain same or conserved. Okay, but now we will do it mathematically. Mathematically it says that firstly we will write the body A and body B. That body A, here I am writing momentum of before collision. It means I just read in the short form that MBC. It means the momentum of body A before collision. Now momentum before collision of body A was m1 and u1, means unequal mass and velocity, initial velocity. After that, in body B, body A is this. I should write here B separately. Just wait. In body B, we are again momentum before collision is equal to, we were having first body A is m1 u1, second we are having m2 and u2. Okay, let me just explain it out. Paragraph remove. Okay, so after this one, this is a momentum before collision. Now after that we will also write that momentum after collision, because here we are having two terms, before collision and after collision. So after collision we receive the mass same m1 and velocity, final velocity v1. Okay, and same over here, that momentum after collision is equal to m2, and here we will be having v2. Okay, so we have find the mass momentum before collision and after collision. Now what we will do, first of all we will write here the total momentum before collision, total momentum before collision, and then just wait, we will write a total momentum here just after collision. Okay, so talking about total momentum before collision, so we are having the body A momentum, that is m1 u1. Now we add the body B, that is m2 and u2. m1 u1 plus m2 u2 is the total momentum of both bodies before collision. But after collision we will be having change, that we are having m1, we are having change in velocity, that v1 plus m2 and v2, m1 v1 plus m2 v2. Okay, now after that we will be using here the rate of change of momentum. Okay, as we have learned in our previous lecture about the rate of change of momentum, rate of change of momentum is equal to force Newton. We have used last time we have used over there the Newton's second law of motion, that is F is equal to mvf minus mvi upon t, short interval of time. But in the place of that, in this time we will use same formula of on body A and body B. So on body A, we will apply formula on body A. So on body A we will written over here that m1 final and then initial, m1 v1 minus m1 and u1 upon short interval of time. With short interval of time, this is we have received, this is called equation 1. Okay, hope you guys are understanding. Just after that, what actual happens, okay, so after this one, Okay, so m1 v1 minus m1 u1 is upon a short interval of time. After that, talking about body B, same in body B we will apply the formula. Body B, we were having that m2 v2 minus m2 v2 minus m2 and u2 upon short interval of time, and this is our equation 2. Now according to these both equations, we will put this one on the third law of motion. According to third law of motion, every action is having equal and opposite reaction. So according to third law, I should write here, according to third law of motion, according to third law of motion, action means fa is equal to minus fb, because every action is having equal and opposite reaction, so we have written that fa is equal to minus fb. After that, according to this one formula, we will putting the values of these. Like body A, we are having m1 v1 minus m1 u1 upon, just wait, upon short interval of time is equal to, here we will be having a sign of minus, and after that I can make a bracket over here. In this one bracket we will write the value of body B. So according to this one equation, second equation, just we are not doing anything, we are just putting the both equations equal to each other. Now let's see how it will. Okay, so talking about it, move to next point. Delta means short interval of time will cut with a short interval of time, means these both, this short interval of time cut with this short interval of time because both are same. After that we will be having remaining just, that is m1 v1 m1 v1 minus m1 u1 is equal to m2 v2 minus, sorry, it's not well minus, when it will multiply, so m2 v2 will be the sign of minus, and minus minus we are having plus over here, so it goes to plus. Then we will write here m2 and u2, not u3, u2. Okay, after that what we will write over here, that these both equations will be changing its side. Like we are having first one m1 v1, it's minus over there, now it will come here, it will plus m1 v1 plus m2 v2 is equal to, after that we are having here minus, so when it will go there it will plus m1 u1 plus m2 and u2. So just we will change their positions, from change their sides from one side to another. Yeah, so now it's proved over here that the body before collision and body after collision is remain same. So let's prove over here that the definition was that when two bodies are collide in isolated system, the total momentum before collision and after collision will remain same or conserved. So you have seen over here that we have proved that the first before collision is equal to after collision. Hope you understand today's lecture. Thank you so much for listening.